Okay. So we still need to mark G, H, J. Yeah. Four to the power of x plus 4 times 2 to the power of x minus 5 equal to 0. Was it better this time around? Did you manage it a bit better? Still struggling? Okay. We'll see where the mistakes were now. Okay, it's going to go on now. Can you tell me so long what happened with that first 4 to the power of x? 2 to the power of 2x plus 4 times 2 to the power of x minus 5 equal to 0. So what I wanted you to realize there is that it is a quadratic trinomial because there are 3 terms and the first one, its exponent is double the second one's exponent. That's how I know it's a quadratic equation. So I put my brackets there. It's the square root of the first one. And then factors of 5 that will give me 4 when I subtract them is going to be 5 and 1. I want to get to positive 4. No. So it has to be plus 5 minus 1. Then I've got 2 to the power of x equal to negative 5 and 2 to the power of x equal to 1. This is not possible. 2 to the power of x equal to negative 5. It's not possible. So I leave that one out, and in this case x will be equal to 0. Did you get it? Do you all understand it? Okay. Alright, h, the 9 I changed to 3 to the power of 2x minus, and I gave that negative 2 its own base. That's 3 to the power of negative 2. Do you all agree it's a ninth? A ninth times 3 to the power of x equal to 0. Now, did you notice, although this is a quadratic, it's not a trinomial. You all see it. When it's not a trinomial, we just take out something in common. Then I'm left with 3 to the power of x minus a ninth equal to 0. Do you understand what I did there? Everyone? So I've got 3 to the power of x equal to 0, and I've got 3 to the power of x equal to a ninth, which can be written as 3 to the power of x equal to 3 to the power of negative 2. Now, is there a way that I can get 0 to be 3 to the power of something? No, because 3 to the power of 0 is 1. So this one is not possible. But this one, x is equal to negative 2. Any questions? You all understand? Okay, J, I saw that there's something in common. It's a 3 to the power of negative x, and then what remains is a 3 to the power of 1 plus 1. I close the bracket and I take the 12 to the other side. Because when I take out something in common, I want the constant to be on the other side. And now when I add these, it gives me 4. So I divide both sides with 4. I've got 3 to the power of negative x equal to 3. You all understand? Okay? So x is going to be equal to negative 1. Are you done? Okay. It was 3 to the power of 2x plus 1 minus 4 times 3 to the power of x plus 2 plus 81 equal to 0. So I hope you notice there are 3 terms. This exponent is double that exponent. And this exponent's base is 3. Okay. So when I rewrite this, This exponent's base is also 3, so it's actually 3 times 3 to the power of 2x. And then 4 times 9, which is going to be 36, 3 to the power of x, plus 81. Now, just for a change, I'm going to use the k method here. So I say 3 to the power of x is equal to k. Always take the middle one equal to k. Then it's going to be 3k squared minus 36k plus 81 equal to 0. Now, if there were some of you that struggled with this one, when it's in the k method, can you maybe see what I can do before I even factorize? Can you see there's something? What is it, Untitled? I can take out something in common. I can divide each term with 3. And then I'll be left with k squared minus 12k plus 27 equal to 0. So what I did there is I divided all of it by 3. I divided the 0 with 3 as well, but 0 divided by 3 is 0. Are you all happy? You all understand? Okay, now I can factorize it. K and k. And then I look for factors of 27 that will give me 12 when I add them. And that is 9 and 3. And it's going to be minus and minus equal to 0. So I've got k equal to 9 and k equals to 3. Now I substitute the 3 to the power of x back into it. 3 to the power of x equal to 3 squared. And 3 to the power of x equal to 3. Do you all understand? X is equal to 2. X is equal to 1. Okay, don't let this one confuse you with that 2 to the power of 3. Let's get this one in prime base form. It's 2 to the power of 4x. This one is in fact 2 times 2 to the power of 2x. Do you agree with that? Karanelu? And then, do I want my third one to be exponential when I've got the quadratic trinomial? No, I want it to be a constant, so I'd rather write it as 8. Okay. Katlego? You understand? And now I can factorize it. It's that one square root 2 to the power of 2x, 2 to the power of 2x, and then factors of 8 that will give me 2 when I subtract them is going to be 4 and 2. I want it to be plus 2, so it's going to be plus 4 minus 2. So I've got 2 to the power of 2x equal to negative 4, and I've got 2 to the power of 2x equal to 2. Can I get negative 4 to be 2? No. And this one is just going to be 2x equal to 1, and then x is equal to a half. Right, m, you had to start with that one, that quarter. I write it as 2 to the power of negative 2x minus 3 times 2 to the power of negative x minus 4 equal to 0. Do you see this exponent is double that exponent? So I can just factorize. 2 to the power of negative x, 2 to the power of negative x, then factors of 4 that will give me 3 when I subtract them, 4 and 1. I want negative 3, so it's going to be negative 4 plus 1. So my answers will be 2 to the power of negative x equal to 4 and 2 to the power of negative x equal to negative 1. This right hand side one is not possible. Can't work with the negative there. So it's out. This one is 2 to the power of negative x equal to 2 to the power of 2, and therefore x is equal to negative 2. Did you get it right? Okay? All done? Done. Okay. The last one, n, from number 1, I helped you with a bit yesterday. 2 to the power of x plus 16 times 2 to the power of negative x minus 10. Did you manage this one? Huh? You did? Okay, let's see. I told you that this one is not double that one. They don't have anything in common. But what I can do is I can get rid of the negative exponent because then they'll be the same. Then it's going to look like this. 2 to the power of x plus 16 over 2 to the power of x minus 10 equal to 0. But now I have a denominator in my sum. I don't like fractions. I don't want to work with fractions. So how do I get rid of a fraction? Is I multiply with the denominator. So 2 to the power of x times 2 to the power of x is going to be 2 to the power of 2x. Here it's going to cancel out. Plus 16. Minus 10 to the power, 10 times 2 to the power of x equal to 0. And 0 times 2 to the power of x will just be 0. So just because I prefer it that way, I'm going to rewrite them in the order that I like it. Plus 16 equal to 0. Now I can factorize. This one square root. And then factors of 16 that will give me 10 when I add them is going to be 8 and 2. And it's going to be minus and minus. So I've got 2 to the power of x equal to 8. And I have 2 to the power of x equal to 2. And this one is 2 to the power of x equal to 2 to the power of 3. So x is equal to 3. And this one is just x equal to 1. Who got it right? Good. Good, good, good. The rest of you, do you understand it? You're going to have to go and take a look at it again over the weekend, alright? Go and redo them. Let me show you with the pencil what happened. So here I multiplied with 2 to the power of x. So these two just cancelled out. That's why I got rid of the denominator. Okay. Alright, number 2. They asked you to prove that the left side is equal to the right side. So at this stage, it's an expression. No. At A, we are not solving x. We are just simplifying to try to get this to look like that. And then I saw that these two terms have got something in common. Did you all see that? It's got the 3 to the power of negative x in common. So I'm left with 4 times 3 to the power of 1 plus 3 to the power of 2 equal to... No, equal to nothing because it's an expression. When I calculate what's inside here, 4 times 3 is going to be 12 plus 9, that's 21. So I've got 3 to the power of negative x times 21. Now they want me to give it as 21 over 3 to the power of x. How does that happen? I make that one positive, then it becomes a denominator. So I've got 21 over 3 to the power of x. And then the left side is equal to the right side. So they say hence solve for x if that whole thing is equal to 63. So instead of taking that long one again, at B I just take the answer 21 over 3 to the power of x equal to 63. Okay, I can't work with it when this is a denominator. So I'd rather write it as a negative exponent. What you could have done as well is you could have multiplied it there and then divided here. I will show you that option as well. Okay, so in this case, normal number, exponential, normal number, that's what I like because then I can get rid of the normal number. So I've got 3 to the power of negative x equals to 3. And then x is equal to negative 1. Did you get it right? The other option that you could have done is you could have said you multiply with the denominator everywhere. Then you'll have 21 equal to 63 times 3 to the power of x. Okay? Then I take that one over, it divides, so I've got a third equal to 3 to the power of x. Then I've got 3 to the power of x equal to 3 to the power of -1, and in this case also x will be equal to -1. It's just another option. Number 3. Did you struggle with number 3? With the surds? Okay, they want you to prove that the left side is equal to the right hand side. So there are different ways that you can do it. I think because most of you are more familiar with the exponents, it would be easier to get it in exponential form, but it doesn't matter, you can use it with this as well. I will show you both options. So the first one is you say it's 2 to the power of x over 2 plus 2 to the power of x over 2 plus 4 over 2. Do you understand what I did there? Okay. So now I take this one out in common, 2 to the power of x over 2, bracket, 2 to the power of 2. No, I don't write the 1. 1 for that one, plus 2 to the power of 2. Happy? Those two added gives me 5, and then I've got 2 to the power of x over 2, but they want it in surd form. So for me to convert this to surd, I'm going to leave the 2. What comes first now comes last. What came last now comes first. 5, and then the left side is equal to the right side. Do you understand? Can I show you option 2? Are you done with this one? Not yet? I'll give a minute. This one. What I did is that was my whole exponent, I put it over 2. Okay? So then you can split it to calculate it. It's x over 2 plus 2. Both of them. Okay. The second option with that one is root 2 to the power of x plus root 2 to the power of x plus 4. Okay, what you could have done as well is you could have kept it in surd form. Then it's root 2 to the power of x plus 2 to the power of x times 2 to the power of 4. Do you understand what I did there? Okay, I just gave that exponent its own base. Now, what happens now is there's a surd rule, which you know, we've used it many times, but it says that you can split these two. You can give each one its own root. And then I can take it out in common, a root 2 to the power of x, I'll be left with 1 plus, now the square root of 2 to the power of 4. 2 to the power of 4 is 16, and the square root of 16 is 4. And then I'll have root 2 to the power of x times 5. So the left side will be equal to the right hand side as well. So it doesn't matter which way you're using it. Hence, solve for x if that whole long thing is equal to 2.5. So you don't use the whole long thing again. you use the answer, and if you couldn't get to the answer, you use the answer that they gave you, equal to 2.5. Third, normal number, normal number. We like that. We take the normal number to the normal number. So I'll have 2 to the power of x square root. This is, if this is, I'm going to show you if you're doing it without a calculator. This is 5 over 2. And you are dividing with 5. Now when you divide with 5, you multiply with the reciprocal. Remember, that's the rules of fractions. And then I'll have left the 2, after 5's cancel out, I'll have 2 to the power of x equal to a half. Now I just need, this is now in third form, this is now in normal number form. I need to get them to the same format. Now I can't write this one as a third. Okay. I can write it as an exponent. I can write it as 2 to the power of -1. And then I can take it over to third, but I don't really, we haven't done sums where we get it from third form to solve x. We have done it with exponents. So I'd rather take that one to an exponent as well. So it's 2 to the power of x over 2. My bases are the same. So x is going to be equal to 2. I multiply with the 2, I multiply with the 2. Oh, you can't see. Sorry. Vanilla, are you checking up on me? Ach, did I not write? I said negative, but I don't write negative. Sorry. Okay, are you done? Okay, we are still busy with exponents. We are still busy with equations. Okay, but now our exponents are going to be rational numbers. So a rational number actually most means a third, but I'm going to show you how to calculate the answers when our exponent is rational. So you can write the heading. Equations with rational exponents. So I hope immediately in your mind's eye you can see an exponent that's in a fraction format. Okay, are you ready for it? Example 1. Who has a plan for me? Remember, when we solve an equation, we want to get x alone. So how can I get that exponent to not be 2 over 3? And I have an equation. What I can do is I can multiply with the reciprocal, the exponent. But then this exponent I also have to multiply with that reciprocal, because if I don't do it on both sides, I'm changing the equation. Do you all understand? So on this side I'll be left with x, and on this side I'll have 4 to the power of 2 over 3. Can I write it as a surd? No? What comes first now comes last. What came last now comes first. Oh, what am I writing? I'm not writing the reciprocal. Sorry. Sorry. You don't correct me either, no? 3 over 2, 1 times 3 over 2. Excuse. Do you all still understand? I haven't confused any of you. Okay, what came first now comes last. What came last now comes first. Okay, now at this stage there are 3 different ways that we can solve this sum. The first one is to first calculate the exponent. So 4 to the power of 3 is 64. Square root of 64? 8. Okay. Square root of 64 is 8. Then we have our answer. That's the first way. The second way is to take the square root of 4 first. What's the square root of 4? 2. And then take the exponent. What's 2 to the power of 3? Once again, the same answer. Third option, I can write 4 in prime number base. And this is what we're going to do, especially when we've got big numbers. Like, for instance, if that was a 20. That would be a very big number. You won't be able to calculate it. So you can write it as 2 to the power of 2 times 3. It's square root, no? And then it's 2 to the power of 6 square root. And then I've got 2 to the power of 3, which is equal to 8. Do you understand what I did there? Let me say again. I wrote 4 as 2 to the power of 2. I multiplied the exponents to get 6. And then I converted it, I took the square root. I said, what comes first now comes last. What came last now comes first. So it's 6 divided by 2. And that's how I ended up with 2 to the power of 3, which also gives me the answer of 8. As I said, you can't decide that you prefer this method over another method, either of the 3. Because in some cases, the one would be a better one than in other cases. Let's do another example. Do you want to try it yourself? 2 seconds. Are you done? I'm done. Okay, so you're going to have 8 to the power of 2 over 3. It's the reciprocal. I write it in third form. Doesn't matter which way you calculated it. Either you say 8 squared is 64, cube root of 64 is 4, or you say the cube root of 8 is 2, 2 to the power of 2 is 4. Or you can write that as 2 to the power of 3, that will be 2 to the power of 6, divide by 3, it will be 2 to the power of 2, which also gives you 4. Maklik. Okay, I'm going to do this one with you just to save us some time. So I'm going to have my reciprocal there, negative 4 to the power of 3 over 2. So x is going to be equal to the root, negative 4. What comes first now comes last. What came last now comes first. So it's a square root of negative 4 to the power of 3. I hope you see the danger lights flickering. Do you see it? What is the danger light, Panele? Square root of a negative. No solution. No real answer. Happy? Yeah. You have to do that in the exam. You all understand why, ne? We can't take the square root of a negative number. It's a non-real value. It's the imaginary friend there on the board. Ne? You see the 8 telling the 4, cute, he has an imaginary friend, referring to 6's friend, who is the square root of negative 1, because the square root of negative 1 does not exist. It's imaginary. D, another example, D. Also, I'm going to do this one for you. Negative 8 to the power of 2 over 3. Now I have negative 8 cube root squared. Okay, and here we come across one problem. Because if we do it in this method, using this method, it will work out. Because we are going to square that, it's going to be 64, ne? And then take the cube root, it's going to be 4. But if we use the correct mathematical method, it's going to look like this. And I don't want you to use the long method. I want you to use the method that we use now. The danger light that I want you just to remember, and this is just something that you need to learn, is when my denominator is an even number, my answer can't be negative. Okay. So I just want you to write this one as no answer, and I'm going to show you why. But write no answer, why, even denominator, negative answer. Okay, so the long method, the long mathematical method that we use is we break this thing up. So we say it's a half times 3. Do you understand that? No? Just broke the, I took the 3 out so that it must multiply in. Equal to negative 8. Okay? So what I do now is I take the cube root on both sides, and I'll have x to the power of negative 2 equal, x to the power of a half equal to negative 2. Now do you see the calculation I'm doing here is taking a half, taking a square root, and getting a negative answer. A square root won't give you a negative answer in a sum. It will only give you a positive answer. So after this, then we'd say no answer. But as I say, you don't need to do it in this way. It's easier, do it in the way that I've showed you with the other examples, but you need to learn that when I have an even denominator and a negative answer, it will give no answer. No, I don't want to do this one with you. I'm going to do another one with you. Let's see if you are awake. Is there anyone who can tell me what sum is this? What type of sum is this? How did you know it's quadratic, Vanele? The first one is double the second one exponent, and there are 3 terms. Good job for seeing it. Do you all see? How do we factorize a quadratic trinomial? What's the secret to mathematics? Everything stays the same. So don't let this whole situation confuse you. Okay? You're going to take the square root of this one. Do you remember with the other ones, when we took the square root of this one, it gave us that one? Because when we take the square root, we are actually dividing the exponent by 2. And a half divided by 2 is mos a quarter. No? So if I were to factorize this, look at the easy factorization. It's x to the power of a quarter, x to the power of a quarter. Factors of 2 that will give me 1 when I subtract them is 2 and 1. I want to get to positive 1, so it has to be plus 2 minus 1. Die klok gaan nou lui. Ja, julle gaan hier klaar sê. Ek dink julle gaan min genoeg wees, hoor. So my 2 answers will be x to the power of a quarter equal to negative 2, x to the power of a quarter equal to 1. Okay. Do you see the danger? Even denominator, negative. So this one, no answer. This one, it's fine, no? I multiply with the exponent 4, and then x is equals to 1. If you put it in the root form, that one. It would be fine, but then that would be a square root, that would be a 4th root. So would you be able to recognize that? You are actually jumping ahead because there's a 3rd one in the homework. So if you come across the 3rd, just take it to exponential. Okay, take it to exponential. If the first one's exponent is double the second one's exponent, no matter what it looks like, if it's double, it's a quadratic function. Okay, so what I want you to do for homework for me for Monday, and it's the last work that is a bit challenging. Monday's work, easy peasy. We're going to do it very quickly, settle it, and then Tuesday we still have time, and then Wednesday we're writing the test. No? So for Monday, it's activity or exercise 9 on page 16. I want you to only do number 1, the first column, and then number 2, all of them. Do you see what I spoke about the 3rd? Alright? So what's that exponent if it's square root x? X to the power of a half, and that's x. What is a half times 2? A half times 2. You've got 2 halves of chocolates. How many do you have? 1. And that exponent is 1. So it's double, it's quadratic trinomial. You can check it with all of them. It's quadratic trinomial. Okay. 1 The first column, so A, E, I, M, Q, and then number 2, all of them. Sharp.